Good morning, good evening, everyone, depending on where in the world you're joining from. My name is Yashas, and today we're going to be talking about data structures. It's a continuation of a couple of sessions on data structures that we have done in the past. And this session in particular is going to focus on the Trie data structure. So just some basic expectations. You are more than welcome to turn on the video and join me. But if you're hesitant to do that, that's fine. During any time in this session, if you have a question, please feel free to unmute and ask me the question, right? We can have a conversation then and there. Or if you want, we can take up questions at the end, right? You can unmute at the end and we can discuss. The questions can be related to what we're talking about, or it can be unrelated as well. Anything that you want to ask me. Um, in addition, also you can drop questions in the chat, but those questions I will only be taking up at the end, right? So just to set some basic expectations for this session, I'm going to be quickly introducing the Trie data structure, and then we are going to be solving a question on the LeetCode coding platform together using this data structure. So it's completely all right if you're new to programming languages, or if you feel that the session is a little fast paced. It is meant to be that way. So you can always access the recording, or you can access more content about Trie data structures online on your own free time. The purpose of this session is to just make you aware that such a data structure exists, so that you're curious, so that you go back and do a little bit of reading, digging on it, and learn a lot more about the data structure. So it's completely fine if you don't understand every single line of code that I'm about to show or demonstrate or explain to you. The overall aim should be you understand what a Trie is, and you understand when to use it, and you're curious enough to go explore it on your own. Okay, so let's get started. So I just want to take a minute to introduce myself to all of you. I did my bachelor's in computer science from BMS College of Engineering, Bangalore, and I graduated from there in 2020. During that time, I was an summer intern at IBM during the summer of 2019. From 2020 to 2021, I was working as an associate software engineer at Danske Bank, and later I joined SAP Labs India as a developer associate. So during this time, I was mostly working in full stack development. I was working on Angular, Node.js, and the application that we were maintaining was a cloud native application. So I was working with a lot of those things as well. And in 2022, I decided to pursue my master's at the University of Illinois, Urbana-Champaign. So I did my master's in information management. So this is a program that was a program more focused on Python analytics, and so I really got to dive deep into Python database administration, that sort of stuff. All right, so let's get started. So before we look at what tries are, I want to hear from all of you. What are trees, right? So you can feel free to unmute and answer what trees are, or if you want, you can drop your answers in the chat as well. But I just want to hear from you. What do you know about trees? What do you think trees are? Don't be shy. Do speak up. Let's just check the chat. Okay, is anyone wanting to share what trees are? Again, it's totally fine if you're not aware of it, or if you get it wrong. We're all just here to learn. But I would love it if you're enthusiastic and you want to have a conversation with me, and you want to answer what trees are. Okay, that's fine. No worries at all. I will tell you what trees are. So you will learn two new things today: what are tries and what are trees. Okay. So this is what a tree looks like, right? So a tree is basically a graph. Now, if you have done data structures or computer science before, you might be familiar with graphs, right? So there is a graph data structure, and a tree is a type of graph data structure that is connected and acyclic, right? So basically, what does that mean? You have nodes, right? These circles that you see, one, two, three, these are all nodes, and these nodes are connected together by edges. Okay, so it's connected, meaning all the nodes are connected to one another. From one particular node, you can reach every other node in the graph, right? And it's acyclic, meaning there is no cycle in the graph. Then it's a tree. This particular example that you see here, this is a binary tree, meaning every single node has at most two children, right? There's a maximum of two children in for each node. Okay, so that is basically a tree. You might already be familiar with it. Now, does anyone know what tries are? Now, this is a concept that is not very well known, but it is very important for FANG or MANG interviews. So, if you have not heard of this before, this is a great opportunity for you to learn it, because a lot of times this is asked in MANG interviews. So, does anyone already know what tries are and wants to share? It's okay again if you want to take a guess. We're all just here to learn. I would love it if you also want to just take a wild guess and tell me what tries are. Okay, looks like you're all hungry, waiting to have dinner. That's fine. Um, I will tell you what tries are, because that's what we're here to learn today. So tries are basically prefix trees. Okay. So what does this exactly mean? So let's say that you have a bunch of strings, right? A string is basically a sequence of letters or alphanumeric characters, right? Or it can have special characters as well. But basically, it's a sequence of characters. And let's say that we have four different words. So what are the four words that we see in this picture? So we see, depending on the nodes, which are the circles, and the edges, which are the arrows, right, pointing, we see that we have one word, P-O-T, pot. We have another word, P-A-S-T, past. We have a third word, P-A-S, and then there's another branch here, so it's S, P-A-S-S, pass. And we have a fourth word, P-A-R-T, part, right? So now these four words, if we notice, have some commonalities. And what I mean by commonalities is they start with one or more of the same letters, right? So if we are trying to represent these four words using a single data structure, now again, keep in mind, data structure is basically a way to represent or store data, right? Now, if you want to store these four words efficiently, right, do we really have to store the common letters again and again? Not really. What we can do is build a prefix tree, which does exactly this, which will basically combine the prefixes or common letters that appear at the beginning into a single node, right? Now we notice that all these four words have the letter P in common, the first letter P in common. So they will all start with the node P, all right? Then we notice that the words PAST and PART, right, and PASS as well, have the two of the letters common, which is P and A. So then we're going to make P and A. Let me just see if I can. Yeah. So we're going to make two of the letters P and A common. And then from there, we're going to branch out. right? So this is sort of like a tree, but what we notice is that it need not be binary, right? Binary means you have at most two children, but here from one letter we can have any number of following letters. So you can have any number of branches from a particular letter, because you can basically connect it with any number of words after that particular letter, right? So in this case, all these three words have the prefix PA in common. So they're going to start with PA, and then we're going to branch out into S and R. Okay. So then there is a third prefix that is common between PAST and PASS. So again, we're going to make S letter common between these two and then branch out and say T and S. So what we're doing here is that the prefix or the starting sequence of common letters, we are combining them into the same nodes so that it is easier and efficient to represent all these words, right? Now, what is the advantage of doing this? Of course, are saving on a little bit of space. We're not representing every single letter. If it's common, we are just combining it into single path in the tree, right? But the main advantage of this is with respect to searching keys, right? Or searching for a sequence of letters. So it is optimal when you want to perform search operations, right? So instead of having to search through four words, what we can do is if we represent those four words using a single data structure like this, which is a prefix tree, we can search through this single data structure itself, right? So the search operation can be many different things that we want to perform, but basically any kind of search operation becomes more optimized, because instead of having to search through four different words for like once each, right, four times you're doing that, we just search through this single data structure because the prefixes have been combined, and it's much more efficient, right? So if you want to search through this, we will say, oh, P, okay, then we check P has two children, O and A, then we go through A, A has two children, S and R, and so on. So that way, search becomes much more efficient. Okay. So now when I keep saying search, right, it's sort of hard to imagine sometimes what we're exactly searching for. So let's take an example of a LeetCode question and see how it's solved using tries. Okay. So this is a question. This is a question. Find the length of the longest common prefix. So I've already loaded it for us here. Let me just zoom in. So I will just be doing a quick walkthrough of the code, right? Again, if you don't follow every single line, that's totally fine. As I mentioned at the beginning, the aim of this session is to introduce you to the tridata structure and get you curious to learn more. And as I mentioned, this is really important for interviews, and it's not a data structure that is very commonly known. So knowing this data structure definitely gives you the upper hand. So let's quickly read this question. So what are they saying here? So they're saying you are given two arrays, right, with positive integers, and these are the names of the arrays. A prefix of a positive integer is an integer formed by one or more of its digits starting with the leftmost digit. So for example, if we have the number 1, 2, 3, 4, 5, 1, 2, 3 is a prefix of it, right? But 2, 3, 4 is not, because prefix means it has to start with it. Then they're defining a common prefix of two integers is something that is common to both the integers. For example, these two integers, right, have 565 as a common prefix. So if we see here, 565 appears at the beginning of this number, and it also appears at the beginning of this number. But is that the longest common prefix? No. There is 5655, which is common, and 5655 again, which is common. So that is the longest common prefix between these two integers, right? Now, and they've also given an example where it's not, they don't have a common prefix. Now the question is, given two arrays of this form, right, we have to find the length of the longest common prefix between all pairs of integers such that the first integer belongs to the first array and second integer belongs to the second array. Basically meaning that if you take one integer from the first array and one integer from the second array, what is the length of the longest common prefix possible between those two? That's just a lot of information, right? But it's okay. We'll go through it slowly. And again, it's okay if you don't completely understand the solution to it right now. You can always go back, take a look at it at your own time. Okay. So, this question, the first clue that you see is prefix. As soon as we see words like prefix, we know that you might have to solve it using tries. Why? Because a trie is nothing but a prefix tree, right? So what we will do in this question is, so first of all, let's think of the brute force approach. The brute force approach would be parse through every single element in the first array and compare it to every single element in the second array and find what is the longest common prefix between those two numbers. Now, when we're doing this comparison, basically what from the information they've given, we have to treat it like a string, right? They're saying that we start from the leftmost digit and one or more digits which are common between the two will become the common prefix, right? So we have to treat each one as a string and then compare the longest common prefix. All right. So that's exactly what we're going to do. So this is the code that we will use to create our trie data structure. Okay. So I've already prepared the code in advance for us because, again, as I mentioned, the aim of this session is just to get you curious and to get you to explore this by yourself, right? So we define tries in Python. So this code is written using Python. Excuse me. We will define tries in Python using a nested dictionary, right? So if you go back to the picture here, what we notice is that we have a first level P and then we have OA, right? So we can represent this using a nested dictionary where the key is P and then we have two values inside that. Rather, that P points to another dictionary inside which has keys O and A, and then the O again points to another dictionary inside which has the value T, right? Now it's okay if you're not completely understanding what I'm saying because I will just execute and show you how it looks like. Right? It looks something like this. This is what the nested dictionary data structure representing a trie looks like. So first we have, so this is a representation of these three numbers, okay? So we have 1, okay? What this hash means is that this denotes that that is the end of the string, right? That denotes that this string came to an end. That means that whatever keys we have accumulated so far, that actually forms a word in the array, right? So now we have only accumulated one key and then we have reached the end in this nested dictionary. But that's not all. We have another letter, right? Or rather, the letter or character representation of a digit here. We have 1 followed by, in this dictionary, we have a 0, right? So 1, 0. So 1 is one of the um, numbers here because there is an end character which we denote using this. Then we have 1, 0, which is also one of the numbers here. Then we have 1 inside 0, again it ends, that's why we said 1, 0 is one of the numbers. And inside 0, if you notice, this is the nested dictionary for that, right? We have another 0. So we have 1, 0, 0. So that is also another number, right? So that's how we will do the nested dictionary representation for a trie. So what we're doing here is we are basically creating a trie data structure and inserting every single number. Again, this number would be in string representation, right? So basically we're inserting every single word that comes in as an argument, right? By looping through every character of the word If that character is not already present, then we create a nested dictionary out of it. Otherwise, we will just, and then once it exists as a key, we will navigate inside that dictionary. Okay. Why are we doing this? Because as I mentioned, for tries, if the letter already exists, we don't have to store or create that representation again. We reuse common nodes for, we reuse nodes for common letters in tries, right? So if P already exists, we don't create that key or we don't create that node once again. And this again, as we saw in our example, represents the end of the try of the word in the try. Then what we would be doing is this function prefix length. Now this is something that we look at when we're looking at the main code. All right. So what we're doing here is, so the idea is that we take one of the arrays and we insert, right? We convert each number in that array to a string and insert it into the trie data structure. So basically we form a trie data structure out of one of the arrays, right? So now we have represented all the elements in array one using a trie data structure. All right. Now what we will do is we will loop through every element in array 2, but we will only compare it against, so this would have been the brute force approach where we do for every element in array 2, we compare with every element in array 1, right? But that's not necessary right now. What we can do is we can just compare every element in array 2 with the trie that we have created out of the array 1. So we already have a data structure, particularly a trie data structure, to represent our array 1, all the words or all the numbers in array 1. So we will compare every number in array 2 with that trie data structure and find the maximum prefix length. Now, how do we find the longest prefix length or maximum prefix length? Again, we will be looping through every single um, character in the number which is provided to us, right? The string representation of the number. And if it is present, we navigate inside. Otherwise, we return the length which is already calculated so far, and we start from 0, right? So this would give us the prefix length for every single string that we try to find. And then we're keeping track of max here to find the maximum or longest prefix length out of all the elements. So for every element in array 2, we compare against the entire array 1 using this trie data structure, and that's how it becomes more optimal. All right, so this is an example of a kind of question that can be solved using tries, right? Again, if this was a little fast for you, that's fine, right? Aim of this session again was to just introduce you, give you an idea, make you aware of it so that you can dig through it later. And I'm sure you'll be getting the recording for this session, so you can check out the recording as well in, slower speed. And you can always reach out to the IntrnForte team or me personally if you want to know this in detail, right? So, but this is a LeetCode question number if you want to take a look at it later. Okay, so that was basically about tries. Now, if you want to learn more about other data structures as well, do check out IntrnForte's data structures course. But right now, we can just discuss if you have any questions in general, anything I can answer about tries, or anything in general that you want to talk to me about as well. I would be very happy to answer. So go ahead.